So you just found out about coherence, you looked at the features and you thought, hey, this is cool, and you installed the SDK for Unity. And now you're in Unity and you're thinking probably, what now? Well, we have a bunch of tutorials and samples for you. The package itself includes some sample scenes that you can explore, very simple stuff. But in today's video, we want to talk about First Steps. First Steps is a complete Unity project which you can download and explore, and it comes with extensive documentation and with 6 separate Unity scenes. It's gonna guide you through some of the most important aspects of coherence. My name is Ciro and I'm one of the creators of the First Steps tutorial together with our graphic designer Theo, and in this video I'm gonna guide you through all of the scenes and explore the concepts one by one. It's a bit of a lengthy video, but it's because we're gonna take some time to explore each concept in depth, but you can obviously use the chapters to skip ahead. Let's begin. When you open the project for the first time, you will be presented with this welcome dialog, which you can close, and with the tutorial window. The tutorial window allows you to jump into individual scenes directly. So for instance, if I press 1, I jump into the scene called 1 Basics, and I can take a look at what's inside. And then if I press previous, I can go back and jump into another scene. And here the panel always gives me some instructions on how to use this particular scene. Otherwise, you can just start from 0 scene selector. So you can press play the game, and then you can jump onto any scene and try them all in one go without having to switch. But for now, we can close the tutorial window, and we want to play this demo and we want to see what it looks like. So the first thing we need to do is we need to bake. You can see that from this little icon here, that's saying that we need to bake to generate the scripts needed for networking. So if I click that, Coherence bakes, and then the little icon shows that we're now ready to go. The other thing we need to do is we need to start a replication server. As you know, Coherence needs that to run. That is our smart relay. And in the case of First Steps, we're using worlds. So we're going to run one for worlds. Now that the replication server has started, we can now hide it. And I've started 2 clients, 2 builds, to show you how this demo behaves. So we can start exploring the different scenes. In this one, I'm gonna log in as P1 and connect to the local world. And now I'm connected to the replication server and my player has been instantiated. In this one, I'm gonna be P2. And you see that immediately I see my player being replicated on the other client. So this is client 1, client 2, and we see the characters moving around, replicating position, rotation, animation, which also reflects when I jump. And then I can press Q to wave. And if I press C, you can see that I can change appearance. And the appearance is immediately reflected on the other client. An interesting thing we built in this demo is an authority visualization view. If I hit the tab key, and I can do it on both clients, you will notice that the graphics shift to a visualization where I now see which network entities I own and which network entities I don't own, so the ones I don't have authority on. So this character here is local for this client, and this one is remote, while of course, vice versa, on the other client, this character here is local and this one is remote. And this visualization will make a lot more sense in other scenes. In this first scene, you will only be able to walk around, wave, and change your cosmetics. Now let's take a look at the first scene from the point of view of the editor to see how it's configured. When we look at the hierarchy, we see a few familiar faces. The first one is the coherence bridge. This is our network manager. You always need a coherence bridge to connect, so make sure that there's one in the scene. The second one is the live query. The live query is a tool for optimizing network traffic. In this case, we decided to have a live query of radius 50, which means that we are telling Coherence that for this client, we're only interested in this area of the world. In this demo, it wasn't really necessary to restrict the live query to 50. Remember that if you set it to 0, this means endless. So you can have a live query that's endless and you don't have to worry of where it is. But always remember that you do need a live query. So you always need one at least in the scene. Then the way the player is spawned, and this is something that interests many people the first time they use Coherence, understanding how to spawn a character, how to instantiate it. Well, instantiating in Coherence is super simple. You literally just call instantiate from the Unity APIs. But in this demo, it's handled by this object. So if we double click on this object, we can understand from the code how the character is instantiated in response to Coherence events. So if I scroll down, you will see that in the awake of this object, we are looking for an object of type coherence bridge. And of course, this is our network manager, as we said. The coherence bridge handles a lot of network events. So once we found it, we want to make sure that we hook into the events on connected and on disconnected. So this means that as soon as we connect to the replication server, this method will be invoked. And this method, of course, sends us to spawn player. And in spawn player, as I mentioned before, we literally just instantiate a certain prefab. And then, we give it a name and we assign a gameplay camera. But all of this is gameplay code. The only thing to mention here that is important to understand is that you don't need to do anything special to instantiate an entity in Coherence. You literally just instantiate and then Coherence replicate it on the other clients or simulators that are connected. And on this connection, of course, we despawn the player, so we destroy. Again, instantiation and destruction, nothing special to do. Coherence takes care of that for you. As we're looking on the first scene, I think the important thing here to do is to also take a look at the characters prefab. So you'll find it here in prefabs characters, and then we open it and we can see the character. You will see that this character is actually a pretty complex entity. Even though this character is an individual network entity, it's composed of many objects, including, of course, some 3D graphics which make the body. There's obviously a bunch of bones that drive the animation. There's objects attached to the bones. There's some particles from jumping, landing, and there's even a 3D canvas which will display the name of the character once the game is running. So pretty complex object, but as I was saying, everything is driven from one component, which is the coherence sink. The coherence sink makes this character a network entity, and the fact that there's only one coherence sink means that the whole character is only one entity. There are cases where this character can hold objects like a crate, but that's an entirely different prefab. The way this network entity is configured, we can see it here. If we click on configure and we dock this window, which I like to dock here next to the inspector, we can now see all the variables that are being automatically synced by coherence. So you see position, rotation, and scaling are synced with default interpolation. And you can always click on more of these things to synchronize something else. But if I do this, I will need to rebake the netcode. So let's not do it right now. You can also see that there's no methods synced here, and there's 3 component actions. Component actions are what allow you to react to the changes in authority on this network entity. So in particular on this character, what we're doing is we are setting the rigid body to be kinematic when the character becomes remote. So this will happen for characters that we don't own locally. They become kinematic, and you could potentially even set the opposite. And you can see that here we also decided to disable the player input and the move script automatically. As we dive deeper into this character, you will notice that there's more component actions and there's more things that are synchronized if I go to here. So more variables that are synchronized at a deeper level. So Coherence can sync variables and methods, and you can create component actions for objects that are children of a network entity. And that's what we did here. So for instance, here the workman object has a few animation parameters synchronized automatically, and that's what drives the animation when we are in play mode. But you will notice that here there's a method that has been synced as well, setTrigger. One thing to note about methods is that you need to invoke the method yourself. So this thing doesn't make the method call itself, because Animator is a component that is built into Unity, so we wouldn't be able to detect when this method is called. So you will notice that actually if we go to the script that drives this character's animation, which is move, you will notice that here we are update animation parameters. We're setting some animation parameters. These ones are being synchronized by Coherence automatically. They are basically these ones. However, for animation parameters of type trigger, we can't just rely on Coherence, like picking up the values of them and syncing them over the network. We need to actually invoke the method, but instead of doing it locally like we would normally, so animator.setTrigger, here I left it commented, we need to send a command. So after exposing it in the inspector, in the code, we need to remember to send a command of the type to the type that we want to target. In this case is the animator. And then as the name of that command, we obviously use the same name as the one we would have invoked, same parameters. In this case is a string, jump. And then we want to use the correct message target. And again, this is done by exposing the methods to coherence by checking it in the configuration window. The second scene is called physics because it's all about creating a physics simulation that is distributed among the clients. So remember that in this demo, there's no simulator, there's no server. We are only working against the replication server, which is just a relay. So the replication server has no gameplay running on it. So where are the physics running in this demo? Well, as I said, they are distributed between the two clients that are connected right now. If I hit the tab key to see authority view, I will immediately notice that the crates, which are physical objects, right now are being owned by P1, by the client that is represented by this window. So if I move around and I grab one of the crates, you can see that I can push them and they are fully physical. They're very heavy, but I can actually push them and you see that they fly around as I would expect. And they, of course, are replicated on client 2 also as I would expect. So how are these crates looking for client 2? Well, right now they are kinematic because client 2 doesn't own them. But as soon as I grab one of them, you see that the crate changes color to reflect the fact that its authority has been transferred to this client. So the authority is now here and it's of course not here anymore. So client 2 can now manipulate this crate in a physical way because the crate is no longer kinematic to them, while the other crates are. So of course, if I push this, they're not going to move. So this is, the limitations of a distributed physics authority. But the beauty of this is that the authority transfer is almost immediate. You can see that when I touch a crate, they become blue instantly. So that means that you can rely on that to create a simulation that is very reactive, but doesn't rely on a server. So this brings the costs of your game way down. So this is a great choice for co-op games where you still want physics and you still want, multiple players, possibly like 3, 4, 10 of them. But you don't care about cheating because it's a co-op game, and then you can shave off the server costs. Looking at this scene from the editor, we can see that the scene is actually pretty simple. It doesn't have much more than scene number 1, except this bunch of crates. So it makes sense to take a look at these crates. The crates are a simple entity. If I go into prefab mode, you will notice that there's just like a element for graphics. At the root, there's a coherence sink, of course, which makes this prefab a network entity. And there's a box collider, rigid body, and then there's a couple of scripts which allow us to manipulate the crate and grab it with a character, which is this script here. This one, actually, coherence node, we provide from coherence, and this is used to parent this entity at a deep level. Because the character, as we saw before, and let's take a quick look just to confirm, it's a very complex entity, and when we grab the crate, it's actually parented to one of the bones. So when we look at the crate again, we need a coherence node component to parent that at a deep level. But the cool thing is that once you have applied this component, you can forget about it because coherence will take care of all of the background work for you. So you don't even need to set anything here. This is just a debug visualization. So the crates, as we were saying, they are in the scene. They're just positioned there, and that means that that's where we're going to see them as soon as we start the game. Because the crates are configured as a persistent entity, you can see it here, it means that even if we leave the scene and we come back to it, we're going to find the crate wherever the characters have moved them. So that's a cool thing you can do with persistency, which we're going to explore in the final scene on this demo. When we saw the game in motion, we talked about having a distributed physics authority. And that means that the crates are basically shifting authority as players manipulate them, shifting it from one client to the other. To do that, you need a couple of things. First, you want to set up the prefab so that the authority transfer is not transferable, but it's either request or steal. Request is the most used one because request allows you to request the authority transfer and answer. So you can answer with a yes or no on the receiving end of the code. Once the crate is set up this way, let's take a look at the code so we understand better the authority transfer and especially the request mechanism. To look at the code, we start from the player's point of view. First thing, there's a script called grab input that the player character has. This one is in charge of reading the input, and then as a result of this grab action, let me make the script a little bit bigger, we can respond to that. So we perform the grab action. And then the thing we do is we are basically checking whether we are in front of a crate by using just simple triggers. When the grab action is performed, we basically do a couple of things. So first thing, we want to look at the grabbable object. The grabbable object is the crate. I'm gonna open it just 1 second. And this is the script that the crate has. So the grab input looks at the grabbable object, the possible target of this interaction, and it hooks into a callback called pickup validated. Pickup validated is going to be our answer to the authority request. So we request the authority, and then the grabbable, the crate, replies yes or no. And then we perform the request. So request pickup sends us here on the grabbable, and now we're in the crate script, and you can see here, this is very simple. The crate will just say, do I have authority or not? So you always have to think that there's always a copy of the crate that is local to us and one that is remote. We're always asking the one local to us, do I have authority? And if I do have authority, I will straight away confirm the pickup of that crate. So character requests pickup, and the crate straight away replies, yes, you can grab me. Because everything is local, so there's no need to request it to other clients. But if the coherence sync of the crate doesn't have state authority, then we go into this other branch. And this other branch, this is coherence APIs, is going to perform a request authority method, which will request the full authority on the crate. Now this method triggers the response, right? Because we set it to on request. So if this is the local version of my crate, now we're looking at the remote version. The one that's on the other client will reply to my request of authority. And if you go here, this is where we have prepared this authority requested callback. So this happens on the other client. And the other client will just respond whether the crate is being carried or not. So this means that if I'm trying to pick up a crate that's on the ground, this is going to return true. And I will receive the authority to that crate. But if I'm trying to pick up a crate that's been already carried by another player, then this is going to return false. So when I see a crate, again, I ask whether I already have state authority on that. I will pick it up. Otherwise, I will request, and then I will receive a response. And then that response will trigger two callbacks on my side, which is on state authority and on request rejected. So if the request succeeds, on state authority will be invoked, which means that now I have this crate and I'm carrying it. And you see that here I'm invoking confirm pickup, which is exactly the same method that I was invoking here when I already had authority. So I end up doing the same thing. But of course, if I don't have state authority, I have to go through all of the request authority flow to end up in the same spot when the other client confirms that I can actually pick it up. You will notice here that we also handle another case because sometimes you can get state authority when you just bump into a crate. So if I was expecting to pick it up, I pick it up. Otherwise, I bumped into it, and that means that I just set the crate to be non-kinematic and I just bump into it, and then the physics engine will take care of the rest. So this is on state authority, but as we said, the request can also fail because on authority request it can return false, and then when it fails, we also have a listener for that prepared, which is going to trigger on request rejected. On request rejected brings us here, and then we have an action here which I have exposed on the crate itself, which is called pickup validated. So the grab input script of the player character is listening to this event, and on pickup validated will react to it. So now we're at the point where basically we requested the authority on the crate because we want to pick it up, and this pickup validated event has been fired one way or another, and we can get a success or a rejection. If we succeed, of course, we're going to pick it up. So the script on the character now knows that we have the crate in our hands, and nulls the potential target. Otherwise, if the request returned false, we go into this branch and we just set this grabbable to null. There's a lot more finesse to this mechanism. You can read the comments. I'm not going to go into detail right now, but you can read the comments and trace all of the functionality between these scripts. So just to recap, it's grab input on the character, calls the grab script, which grab takes care mostly of animation and setting the parent and stuff like that. But in reality, grab input speaks with the grabbable, which is the crate itself. And on the crate side, we do a lot of the authority requesting and authority replying, which happens on partly on our client and partly on the client that currently has authority. I think for this scene, because of this authority transfer back and forth, it really makes sense to take a look at it also in the editor. So let me use Unity multiplayer play mode to start 2 instances of the editor so we can inspect what's happening to the crates as we play. Here we are, and you can see that because these crates are persistent objects, we already find them in a certain state. So the state has been restored as I connect. And if I go into authority mode, they all belong to me because I'm the first player to connect. But as this player connects as well, here we are. Now we see the situation from both points of view. Having 2 editor allows me to show you what's going on behind the scene by inspecting crates using the inspector and the hierarchy. You can see that from the point of view of this character, which is P1, none of the crates belong to them, so you see that the coherence icon here are all empty, except the one for the player, which of course is this character here. But let's say that, for instance, I want to target one of the crates, let's say this one here. So it's this one is the first one. If I go here, as soon as I press the E key, or even if I bump into it, I'm gonna perform an authority request on this crate to this client here, because this crate is not local to me. So if I do that, I click, and now the authority request has been responded to and has come back with a validation. So then the authority of this crate has been passed to this client. If I press the F key now, because I think I have the crate still selected, I can see where the crate is, and you can see that the crate is now parented to the player character at a deep level. That's why we need, as we mentioned before, we need the coherence node. You can actually see the path here of all the children that are inside this network entity. So network entity 1 is the player, network entity 2 is the crate and has been parented to it. If I release, the crate is unparented and is just like dropped in the scene. And then if I grab it again, it's parented again. You can see that here. And this shows the other case where the crate is already authoritative. So if I grab it now, none of this code is running except when I use when I do grab input. I'm just basically requesting the pickup, and then as I go into the crate, it's confirmed straight away because the crate is already authoritative for me. So this is the case where requesting pickup gets confirmed locally because I already have state authority. While if I don't have state authority, I request it as we saw before, and then the request goes to the other client who is supposed to reply yes or no. So this is the case here, for instance. But you can see that the authority transfer is pretty instantaneous. As soon as I bump, maybe there's 1 frame delay, and then immediately I get authority over these crates. But of course, if I am, for instance, holding a crate with this character, and I go here and I bump into it, and I even press the E key, here the requests are always coming back with a rejection because it's being carried is true. So this returns false, and then here I will enter in this on request rejected path. So that's pretty much how you can do authority requests. Authority requests can be useful in many occasions. This one was the case of one of them, but you can probably think of like vehicles that you can take control of, or like something to pick up from the ground, like a weapon or a tool, or even potentially possessing another character. Scene number 3 is called Areas of Interest. This scene again, doesn't really provide you much in terms of gameplay. You can just move around and jump and wave. But you can see immediately that there's two big cubes in the scene. They represent areas of interest, or how we call them in coherence, life queries. Life queries are usually invisible, but in this scene we made them visible. So the thing you can do here is you can move out of a life query, and you will see that while your character here, which is of course local, stays visible, in the other client, it has disappeared because the character is now outside of a live query. So from the point of view of client 2, they're not visible anymore because only the replication server knows about them, but the replication server is filtering out that information for client 2. This is how you can create optimization for big worlds. You basically define live queries to determine which areas you're interested in, and then you can even move the live queries with the characters. And as soon as other characters or other entities, they go outside of a live query, they disappear, they get despawned. And then as soon as they come back in, they can be spawned again. So you see that the entity is then immediately replicated again on this side. Taking a look at scene number 3, areas of interest. This scene is actually pretty simple. There's not much to say here, nothing to it except the fact that this scene has 2 live queries that have been set with a very small radius, and that allows you to create areas of interest. Again, in a normal game, what you will do is you will probably parent this live query to a character or to the camera and move it around, because live queries can actually be moved, and that will determine the area of interest for that particular client. So you could optimize network traffic for a big world. Scene 4 is all about parenting. As you can see, I've connected first with client 1, so P1, which means that now on this client, these platforms, which are also network entities, are local because they were the first one to see them. So the entities are now controlled by this client. What happens on this side is that I can actually jump on this platform, and even though this platform is remote to this client and the character is local, they are parented to each other and move in a very convincing way, even related to each other. So I can move with the character on the platform as the platform moves, and nothing gets like jittery or the character doesn't lag behind the platform, even though the character is being run here and the platform is being run here. So this scene demonstrates how coherence can be solid when it comes to parenting entities and smart about it. You can even, for instance, like disconnect this character. The authority of the platforms gets shifted to the second client seamlessly, and now this client owns the platforms and can, of course, be parented to them. And I can reconnect here and I see the platforms again, and the game continues without any kind of hitch. And this is all handled by coherence automatically. Parenting is just done by setting a parent on a replicated network entity, and coherence will take care of tracking that parenting for you. So you don't need to really program for it. This is another scene where you can really see coherence doing its magic. In particular, this one is about parenting entities, and you can see that here there's a couple of moving platforms, elevator platform and train. They of course have a script which moves them on a spline. So in time they will just like move and synchronize their position. If you go to the configuration of this entity, you will see that position, rotation, and the timer, which is the position on the spline, have been synchronized. The setup here is super simple. When the character jumps on it, detects the platform. The platform of course has some colliders and parents itself to it, and that's pretty much it. And coherence takes care of the parenting on the replication server and of keeping the entities in sync. To note here is that the character doesn't have a coherence node component, because when we parent that network entity to this one, we just parent to the root of the train. If we were to parent the character to one of these objects, we will need a coherence node component, which again is the one that the crates have, because the crates need to be parented at a deep level. So this parenting entity scene is just showing level 1 parenting. And we have some information on the documentation on these 2 types of parenting. But parenting here is only done by setting the parent to the other object. And to show you, I can actually jump into the player script in move. If we search for recasting, we will see that this method here, get onto platform, when it detects a platform, it will just do transform, set parent. So you can see how simple it is to parent entities. With coherence, you literally just pass the transform as, this is Unity's APIs, right? It's not coherence. And then coherence takes care of keeping them in sync. The fifth scene, complex hierarchies, is also a scene that doesn't look like much because coherence is doing a lot of the leverage behind the scenes. In this scene, you can see this robotic arm, which is a network entity, of course, and the crate that the robotic arm can grab is also a network entity. And of course, the crate is parented as soon as I grab it, and it can be left in world space again when I release. The robotic arm is only one, so only one player will be able to control it at a time. And that's why you don't have an actual character here in the scene. But you can see that the robotic arm is replicated here. The interesting thing here is the robotic arm is a complex entity that has several objects being parented to each other and rotating. But we'll see from the setup that not all of the rotations are synchronized, but it's just being calculated locally. And the crate, which is another network entity, is parented at a deep level. The base of the crane is actually the root of this object, and there's several objects being children of it, and the crate is parented to the innermost child. And the way you achieve this setup is by using a component called coherence node, but we'll see more in the editor. This scene is more interesting when seen from the editor point of view. It's called complex hierarchies because the robot arm, as we mentioned, is a complex hierarchy. If I hold the Alt key as I expand the hierarchy, you can see how many objects make it. And you can notice that there's some objects at a deep level which have been configured to network some properties. So if I go into prefab mode and I select them, you can see that there's quite a few parameters here, like for example whether it's carrying an object or not, or which which transform is currently targeting. And here you have the position of these objects, here the rotation of this node. And if you go down the hierarchy, there's the rotation of the base that is synchronized. The reason why I didn't network the rotation of the in-between objects is because this robot arm has a rig, so it's using animation rigging to do IK, right? So the IK is basically resolved locally. We only need to synchronize the position of the IK target here, and then the IK script will resolve the rest of the hierarchy. The only thing worth mentioning again, perhaps, is that the crate here that is being parented, because it's being parented to the grab point, which is a deep object in the hierarchy, requires we said it already, a coherence node script. The coherence node script is a script that does many things automatically for you. As you parent this object using regular Unity APIs, this will just keep track of where in the hierarchy the object is, but you just need to remember to add it. So if you plan to parent an object deeply in the hierarchy of another network entity, in addition to the coherence sync, you just need to remember to add a coherence node, and that's it. The final scene is all about persistence. Persistence is a feature that we have built in coherence and available to all network entities. So you can mark a network entity to be persistent, and coherence will save it on the replication server even though all clients might be disconnected. So for instance, I can walk around and by pressing P, I can plant a flower, and these flowers are persistent entities, while the characters are not. So if I disconnect, my character is destroyed, but the flowers stay. Even if this client were to disconnect and then we connect again, you can see that the flowers are still there, even for this client. And obviously, if I hit the tab key, I can see authority, and I notice that the flowers are being run by this client because they were the first one to see them. The interesting thing is that even if I disconnect, now I will let some time pass and speed up the recording. But if I reconnect after some time, you will notice that the timer on the flowers has already advanced to a certain point. Now, this is not because there's some server-side logic to it, because the replication server, as we said a couple of times, cannot run gameplay logic. It's not a server, it's a relay. But the smart trick here is that because these entities are persistent, we can save the time when they were created, and then when we reconnect, we recalculate the time instantly, and we display to the user a UI that shows progress. It's as if these flowers were growing on the server when actually nothing was happening until I reconnected again. So I disconnect, and right now nothing is happening. The entities, you could say that they are frozen in time, but we know their creation time. So when we reconnect, we can recalculate the timer and display an advanced state. And again, if I disconnect and I let some time pass, when I reconnect, you will notice that the flowers have withered. And it's not, again, because they withered on the server, but because as soon as I see them, I display them in a withered state. So with a little bit of smart programming, you can achieve a lot without actually having a simulator running. And again, not having a simulator running means that you keep your costs down. This is an interesting opportunity that you have with coherence to create persistent entities, and then with a little bit of smart programming, you make them look like they were existing beyond the actions of the players. The gist of the persistent scene is contained in a couple of objects. The flowers counter is an object that takes care of counting the number of flowers that have been planted and ensuring that there's no more than a certain number of flowers at any given point. To do so, this is a network entity. It's set to be unique. So you can see here it says no duplicates, and it's been assigned a manual unique ID. So this means that when I join this scene and I see this network entity for the first time, and then another client sees the same network entity, they're not going to bring a new fresh copy. Coherence is going to know that this is supposed to be the same because the entity has been set to no duplicates. So this can act as a sort of like game manager, if you want, and a shared, we're both looking at the same entity because it's unique. So at that point, we can use this count number as a unified and shared counter of how many flowers there are in the scene. You can see that it's set to 0 at the beginning, but of course, as I press play and I connect, this might be synchronized to any kind of number of flowers that are in the scene. If you look at the code of this counter, it doesn't do much, but it just keeps the count of the flowers. But the thing that really does the work is the flowers handler. Flowers handler is this object here. It's not a network entity. You can explore this script by yourself, but basically the gist of it is that it just searches for the flowers in the scene and updates the counter if you have authority over it. Otherwise, it will react to the number of flowers that is synchronized by the other client that has authority, update the UI, which is this one here, and of course, keep you from spawning more flowers than you are allowed to. The other interesting thing here is the flowers themselves, of course. If we go to the prefabs and nature and then flower, the flower is a simple 3D object. It has a UI and it has a bunch of renderers, which are basically the different states of the flowers. At the root, there's a coherent sync, which makes it a network entity. You can see that there's the lifetime is set to persistent, which is obviously the key element of this object. So they persist and they stay. And it's also set to auto-adopt orphan. This property means that basically when this flower is left, let's say, alone on the replication server because no client is connected, it becomes an orphan. But then as soon as it's seen from a new client, it will be auto-adopted. So the first client to see this flower again will take authority over it and begin running it. And as we saw in the live demo, the flower is communicating its state through these renderers and through a UI. And the UI is relying on this synchronized property called time planted. If you go in configuration, you will notice that this is the one that's been marked as synced. So upon planting this flower, we just like note down which time it has been planted at. And then when we see the flower again, we can then do a calculation and update the UI and update the renderer to display the current state. So that's what I was referring to when I meant that the flower is not actually doing anything in the background when no one is connected, but when the first player to see them connects again, they back calculate the age of this flower and then they display the correct state. If you're thinking, is this open to cheating? Yes, this is open to cheating, but as always, when we think of shared authority, this is also very cheap. This is a very cheap way of doing entities that have some seemingly logic on the server without actually having a server. But the beauty of this is that, of course, you can literally just mark an entity as a network entity to be persistent, and then coherence takes care of persisting it on the replication server for you. So this is a very interesting way to prototype or even like launch a game that has some persistent scene entities without having to code it yourself. Wow, that was a journey. We hope we managed to convey some of the basics of coherence and what a cool framework it is. As next steps, what we will suggest is to take a look at the sample scenes included in the package, maybe explore first steps by opening it in Unity or exploring Campfire or one of our video tutorials. We have a lot of resources. And now onto making your multiplayer game. Have fun!